All right, so this is question 1 in the Math Counts Week 2 handout, and it says, Gene has $52 in his wallet. He has some $1 bills, some $5 bills, and then some $10 bills. If he has 3 times as many $1 bills as $5 bills, and then twice as many $5 bills as $10 bills, how many $10 bills does he have? So basically, this is giving us 2 different types of information, right? It's telling us how much money Gene has total, and then it's also giving us the ratios for the amounts of different bill types. So according to this information, we can write a few different equations that'll represent these relationships. So the first thing I want to do is, it might get confusing since we have a bunch of different types of numbers. We have dollars and then we have amount of bills. So we're going to create variables to represent the amount of each type of bill. So the quantity of $1 bills, we're going to call that A. And then the quantity or number of $5 bills, we're going to call that B. And then our amount of $10 bills, we're going to call that C. So, for example, if we wanted to represent how much money we had in $10 bills, we would represent that as 10C, because each $10 bill is worth, of course, $10. So the amount of money we have in $5 bills is 5B, and the amount of money we have in $1 bills is represented as 1A. And so this gives us the total amount of money we have total, which they say is $52. Next, we want to represent the relationships between the amount of money for each bill. So for example, it says Gene has 3 times as many $1 bills as $5 bills. So that means A is equal to 3 times B, right? Because the quantity of $1 bills is 3 times the quantity of $5 bills. What else? We have twice as many $5 bills as $10 bills. So we can write that as B, the quantity of $5 bills, is 2 times the quantity of $10 bills, which is, remember, C. So now we have 3 different relationships, and we want to use these 3 different relationships to solve for the number of $10 bills, which is C. So what I'm thinking is, let's put this entire equation in terms of C. Well, this is already in terms of C, but this isn't and this isn't. So we need to find how many C's go into 1A and how many C's go into 5B. Well, we can see from this equation right here that 1B is equal to 2C. So 5B is just equal to 5 times that. It's equal to 10C. But what about here? This just gives us the relationship between A and 3B. Well, if we think about it, we know that 3B is equal to 3 times 2C, which is 6C. So that means if A is equal to 3B and 3B is equal to 6C, well, that means A is equal to 6C. So knowing that, we can plug all of these values into our first equation right here. So 1A is, I'll move that there, 1A is equal to 6C, 5B is equal to 10C, and then we have, of course, 10C here, which we don't have to change, and that's equal to $52, which tells us that 26C is equal to 52, and therefore C is equal to 2. And remember, C is our quantity of $10 bills, which is what we're looking for. So the answer right here is just 2.